Hi, everybody, and welcome to Mysteries of Sleep World. How could we set foot on Mercury? You are floating now, eyes soft, breath steady as the stars whisper their secrets, and Mercury creeps into view. There it is, the runt of the rocky planets, closest to the sun, small enough to fit inside some of our moons, but wild enough to ruin your day in under 10 seconds. The sunlight here isn't sunlight. It's a 400-degree C blast of pure judgment. There's no atmosphere, no clouds, no kindness. On the night side, temperatures drop so low your teeth would crack just thinking about it. And yet, we dream about standing there. Why? Because humans are weird like that. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And I'd love to know, where are you watching from and what time is it where you are? Drop your city and your current time in the comments. Let's make this a global stargazing club. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You trudge toward the blinding edge of Mercury's Terminator line, the razor-thin divide between boiling day and freezing night. There's no air here, no blue sky to gaze at. Above you, the sun hangs monstrously huge, looking less like a ball of light and more like a threat. And you're in a suit, kind of. Not a NASA jumpsuit with cute patches and flags, but a pressure-sealed, radiation-shielded, temperature-adaptive exoskin that took 30 years to prototype and 10 more to not kill its testers. And even then, it might still decide to give up halfway through your trip across the planet's equator. Welcome to Mercury, where every step is a gamble and every moment is borrowed time. The weird thing is, Mercury doesn't look that scary. It's rocky, gray, dusty. If you squint hard enough, it resembles our moon minus the cool Earthrise view. But looks lie, because this place doesn't play fair. During the day, surface temperatures can fry a pizza in minutes, literally 430 degrees. That's over 800. Touch the wrong rock and your glove starts to melt. And at night, you're suddenly in a freezer colder than Pluto. One fun fringe fact: in 2022, a group of engineers in Norway tried simulating a Mercurian day-night cycle in a lab oven. The result? The electronic sensors failed in under 11 minutes, and one of the temperature-resistant tiles cracked audibly. They called it Mercury Madness, which sounds like a lost energy drink, but was actually just Tuesday for them. Historians still argue whether the first serious thought of visiting Mercury came from science or sheer boredom. Some credit Giovanni Schiaparelli in the 1880s, who charted Mercury's weird rotation and hinted that perhaps it never turns. Others point to 1960s Cold War dreams, where rockets and egos raced each other into hotter and hotter destinations. One thing's for sure, Mercury was always more of a dare than a destination. Back to you, standing there. Your boots press into a crust of silicate that's older than any fossil on Earth. Each step sends a slow-motion puff outward, no wind to move it, no air to carry it, just floating particles, like a lonely space snow globe. There's a quiet here that presses in. No breeze, no bird song, not even the hiss of oxygen leaking, because that would mean you're dying, and we're not doing that yet. Mercury doesn't orbit like a well-behaved planet either. Thanks to its weird ellipse, its distance from the sun fluctuates wildly. Sometimes it's 46 million kilometers out, other times 70 million. So while it's always the closest planet to the sun, it doesn't stay the same kind of close. And then there's the gravity only 38% of Earth's. You take a step and your foot lands slower than it should. You could probably jump twice your height here if you weren't weighed down by 200 pounds of gear and existential dread. You pause. The silence stretches. Somewhere in your suit, a cooling system whirs quietly like a sleepy fan. You feel heat from below rocks storing the sun's fury and the cold pressing in from the black sky above. This planet doesn't breathe, but it broils and freezes with every rotation. Funny side note, one theory floated by a rogue planetary scientist who may have had too much espresso suggested that ancient alien civilizations could have used Mercury's wild energy cycles to power space beacons. No evidence, no peer review, but a great premise for a bad sci-fi movie. Still, Mercury is magnetic literally. It has a magnetic field, though no one fully understands why. Theories swirl. Maybe its iron core is still partially molten, spinning just enough to generate a dynamo. Maybe it's leftover heat from a violent collision in the early solar system. Historians still argue whether this field is a fluke or a clue. And you? You're still standing watching the horizon slowly boil, the stars behind you fading as the sun edge creeps forward. Out here, your only protection is what you brought with you. No atmosphere to stop a solar flare. No clouds to filter ultraviolet. Just you, your suit, and the will to not spontaneously combust. There's a strange beauty to it all, like sleeping in a lava lamp that occasionally wants to kill you. And yet, part of you wants to stay, to build, to dig, to understand. Because that's the human curse, isn't it? We see the most unwelcoming corners of existence and say, let's try it anyway. You're sweating now, but only metaphorically, because real sweat would instantly evaporate in the savage sunlight of Mercury. This isn't a walk in the park type of planetary exploration. This is a survival puzzle set on expert difficulty. And the first piece of the puzzle? Your suit, or rather, the armor you need to exist for more than 10 seconds on this volcanic space rock. Designing a Mercury-ready spacesuit is like trying to build a house that survives both inside an oven and a walk-in freezer at the same time. The sun-facing side of your body might roast at 430 degrees Celsius, while your back could be chilling at 180 degrees, depending on your position near the terminator line. Thermodynamics doesn't care about your feelings. To deal with that, your future suit needs what engineers call active thermal regulation. We're talking liquid cooling tubes, heat-reflective outer layers coated in materials like beta cloth, and integrated phase change materials that absorb heat when things get spicy and release it when Mercury throws shade literally. Here's the kicker. The suit can't just protect you from heat. It also has to block radiation. Without an atmosphere or magnetic field thick enough to help you out, Mercury's magnetosphere is cute but not helpful. Solar radiation hits raw. That includes UV, X-rays, and even gamma bursts during solar flares. So the suit's outer shell also gets to play personal radiation shield, which makes it more like a wearable space bunker. Mainstream history tells us about NASA's Apollo suits, marvels of their time, but not nearly fit for Mercury. Those suits were built for the moon's relative chill. For Mercury, you'd need something closer to the theoretical suits proposed for Venus missions, but more flexible. Not bulky like a tank, but nimble enough to let you move without dislocating a hip. A fringe idea that floated in the early 2030s involved reflective metamaterials, engineered fabrics, that bounced specific wavelengths of solar energy. One prototype glowed like a disco ball and nearly blinded its test crew in Nevada. It didn't pass OSHA guidelines, but it made for an epic GIF. Historians still argue whether the first fully heat-tolerant spacesuit was a solo genius effort or a collaboration of 10 competing agencies trying to one-up each other. What we do know is that once Earth realized Mercury wasn't going to offer any mercy, the suits became personal spacecrafts. Tiny capsules worn on the skin, each packed with sensors, radiators, and backup systems that could keep you alive when everything else failed. But there's another little problem, the sun. On Mercury, it's 11 times brighter than it is on Earth. And no, sunglasses won't help. You need multi-layered, gold-coated visors just to look toward the horizon without burning your retinas. In fact, you might wear two visors, one for standard solar intensity, another that flips down like an eclipse viewer. Bonus, they make you look like a very stressed-out Power Ranger. Every part of the suit needs to be aware. Smart textiles, temperature sensors, even muscle-actuated joints that anticipate your movement to reduce fatigue. Why? Because on Mercury, every calorie of effort matters. You're carrying 80 to 100 kilos of gear, you're dealing with bone-like gravity, and if your leg cramps, you're one oxygen leak away from becoming cosmic jerky. And there's dust. Oh boy, there's dust. Mercurian regolith is sharp, dry, electrostatically charged, and it gets everywhere. Moon astronauts already complained about this, but on Mercury, it's worse. No atmosphere means no erosion, so these microscopic shards of ancient rock are basically space glitter mixed with sandpaper. Your suit must seal tight, repel dust, and shed particles like a waterproof duck in a knife factory. The suit's base layer, probably lined with carbon nanotubes or some future synthetic mesh, lightweight yet tougher than Kevlar. It has to resist punctures, stretch when you stretch, and not feel like a coffin. One poor test pilot in 2040 had a breakdown mid-simulation because the prototype made him feel like a shrink-wrapped turkey. And let's not forget the hands. You'll need full dexterity for picking up samples, tapping screens, or flipping off a malfunctioning drone. So the gloves are fitted with pressure-compensated actuators and electrohaptic feedback. They know what you're touching and simulate resistance, texture, even temperature. Because trust me, touching something on Mercury shouldn't feel like nothing. That's how mistakes happen. One experimental feature still in debate: biosensor infusion. Basically, the suit constantly tracks your vitals, heart rate, oxygen, cortisol, hydration levels, and adjusts itself. If you panic, it can increase cooling. If you faint, it alerts your support drone. If you forget to eat, which you will because of stress, it flashes a passive-aggressive warning across your visor. Your glucose is lower than a space agency's budget. Consume nutrients now. Even with all this, the suit isn't bulletproof. Stay too long in direct sunlight, it fails. Push it too far past the shadow line, it freezes. A micrometeorite punctures your knee joint, you're done. Game over, thanks for playing. So is it worth it? That's the haunting part. Even with the best tech, the smartest suits, the years of preparation, every moment on Mercury is a negotiation with death. You don't dominate the planet. You ask politely to visit. And if the suit says yes, you keep moving. The problem with landing on Mercury isn't that it's far away, though. Let's be clear, it's no weekend road trip. The problem is that Mercury refuses to meet you halfway. No atmosphere means no air braking, no resistance, no mercy. If you're coming in hot, you're staying hot, possibly forever. So here's the challenge. How do you land on a planet that's actively trying to swat you out of the sky like a solar-powered mosquito? You start by slowing down a lot. The average spacecraft headed to Mercury has to do more than just fire its rockets and aim. It has to unwind its speed from Earth's orbit, then fight the sun's gravity the closer it gets. That's like trying to stop a sled from going downhill by running backward up the hill while it's on fire. Historically, only a few missions have even tried to get there. NASA's Mariner 10 in the 70s got some great flyby photos. Then there was Messenger, which actually orbited the planet for a few years before crash landing into it. And Bepi Colombo, a joint European-Japanese effort, is en route with a new plan, a lot of patience, and presumably a very nervous mission control team. Fringe engineers once proposed using solar sails to slow down. Yes, literal sails. The idea was to catch photons and gently decelerate toward Mercury like a cosmic kite. Cool on paper, slightly suicidal in practice. The sun is, after all, not a fan of being approached. The more reasonable method? Gravity assists. You fly by other planets, Venus, Earth multiple times, bleeding off speed like a figure skater doing wide loops. Bepi Colombo's taking 9 years to get into Mercury orbit this way. It's basically space tourism with a tight budget. Once you're close enough, the real landing game begins. Without an atmosphere, you can't use parachutes. Nope. Instead, you need retro rockets. And not just any rockets, these babies have to fire with subatomic precision. Burn too early, you fall short. Burn too late, you pancake at 12,000 kilometers. This is where autonomous landing systems come in. Think AI-guided descent modules that can scan the terrain in real time, identify boulders the size of buses, and adjust trajectory mid-fall. One proposed system from 2045 used something called terrain relative navigation, where the lander constantly compares the surface it sees to a preloaded 3D map. If there's a mismatch, it says, nope, and finds a better spot, ideally one that doesn't end in crater-based humiliation. Historians still argue whether the first safe landing on Mercury was even human. Some claim it was a crude test lander in 2059. Others say the honor belongs to an autonomous robot in 2056 that beat the humans by 3 years and also had better Instagram filters. So let's say you land, you're alive, for now. Welcome to your new best frenemy, Mercurian regolith. It's not soft, it's not fluffy. It's like the crushed bones of 1,000 asteroids scattered across plains named Caloris Basin and Kuiper Crater. The landing gear digs into it slowly, then settles with a final hiss of escaping gas. You check the suit's sensors. Nothing exploded. A good start. But here's the kicker. Your lander is melting. Even with advanced heat shielding, the sun-facing side of the craft starts heating up immediately. Some designs combat this with rotational symmetry, slowly turning the craft to distribute heat like a rotisserie chicken. Others deploy heat shields that unfold like giant umbrellas to block solar radiation. They look cool. They sometimes work. Meanwhile, the crew capsule inside needs constant cooling. Cryogenic systems circulate supercooled liquids around electronics and life support. Even the storage locker where your freeze-dried snack pouches are kept is lined with reflective foil like a cosmic lunchbox. Fun side note, in 2038, a prototype lander tested a heliophobic paint design to reflect 99.9% of solar radiation. It worked fine, until it accidentally reflected a concentrated beam back into its own fuel line and triggered a minor incident, which is NASA speak for very loud mistake. As you sit strapped in, watching the planet's surface crawl closer through a visor or viewport, you realize something humbling. Every calculation, every algorithm, every line of code in this landing sequence had to be perfect. You don't get a second try on Mercury. There's no bouncing off the atmosphere. There is no atmosphere. It's rock, dust, and regret. Your thrusters fire again. The surface rushes up, gray, cracked, and totally indifferent. And then, contact. A soft thud. The module vibrates like a sigh of relief. You don't die. That's the best-case scenario. Outside, it's blinding. You run a systems check. Radiation levels? High but manageable. External temp? Climbing. The lander's insulation groans. You've got 6, maybe 7 hours before the sunlight begins warping metal, boiling fluid, and cooking electronics. There's no set-up camp moment here. There's only work fast or cook slowly. The missions have been programmed down to the second. Instruments deploy, probes launch. Seismic detectors get stabbed into the dust. You and your crewmates scramble through tasks like over-caffeinated ants on a frying pan. And when your timer says depart or roast, you listen. Escape trajectory locked. Heat rising. Systems redlining. Time to lift off before the sun decides it doesn't like visitors. You thought landing was hard? Try staying cool when the closest star in the neighborhood is blasting you like a spotlight from hell. You step out onto Mercury's surface, and it's instantly obvious. There's no shade. None. Nada. You're on a rocky desert with no atmosphere. No trees, no clouds, just the raw, direct sunlight of a furious star that's 11 times brighter and hotter than anything back on Earth. If Earth's sun feels like a warm hug, Mercury's sun feels like it's auditioning to be your cremation furnace. Here's the fact of the moment. You're now walking across terrain that's easily hotter than the surface of a pizza stone in a commercial oven. We're talking up to 430 degrees Celsius, 800 degrees Fahrenheit in daylight. That's hot enough to melt lead, to bake cookies without an oven, to make your boots think deeply about their life choices. But don't worry, your suit's still working. For now, because unless you've brought a portable shadow, you're on the clock. Even the most advanced suits layered with reflective surfaces, heat distribution tech, internal cooling gels can only hold up for so long. So engineers proposed a clever solution. Bring your own shade. Literally, these were called adaptive sun shields, umbrella-like drones that hover above you at all times, automatically adjusting to the sun's position, casting a mobile patch of shadow over your body like the world's most aggressive beach parasol. Cute idea, until you realize that winds don't exist here, but microgravity and solar pressure do. Those sun shields need constant micro-adjustments to avoid tipping over or drifting off like space jellyfish. Some designs even use magnetically tethered drones floating a few feet above your head, syncing with the suit's orientation and tracking solar angles 500 times a second. Problem is, if the drone fails, you're toast, literally. Historians still argue whether the first shadow drone deployment on Mercury was a success or a PR stunt. Some say it saved an EVA mission from overheating. Others claim it just made astronauts look like fashion-forward jellyfish. Still, some went even further. One fringe group of lunar engineers pushed the idea of wearable mirror cloaks, full-body garments lined with adaptive mirrors to reflect sunlight away like an invisibility cloak. Except instead of hiding from enemies, you're hiding from the sun itself. A little sci-fi, a lot terrifying when you realize one cracked panel equals third-degree vaporization. And what about just hiding in buildings? That works great if you have time to build them. But on Mercury, the moment you step out, the clock is running. Every structure would need to be partially buried or mirrored, sealed tighter than a submarine, and capable of internal cooling strong enough to chill soda cans next to volcanic rock. That's why a big part of any Mercurian mission would revolve around solar time management. You don't just go outside. You plan excursions around meridian angles, solar elevations, and terminator lines, the border between day and night. Stick too far into the sunlit zone and you're dealing with exposure that'll fry your internal organs faster than you can say NASA's insurance policy. That's right. You might do your entire mission, land, walk, drill, and sample all within a narrow twilight strip, a sliver of the surface where light and shadow blur. That's your only safe haven, a constantly moving twilight, shifting as the planet slowly rotates. Miss your window, and you either freeze or flash boil. Want a weird fact? Even though Mercury is closer to the sun than any other planet, it's not the hottest in the solar system. Venus takes that crown. Why? Atmosphere. Venus's carbon dioxide cloak traps heat like an insecure furnace. Mercury, meanwhile, has no insulation, just brutal highs and shivering lows. So despite the scorching daytime, Mercury is also a planet of extremes. On the night side, you freeze. On the day side, you fry. Which is why engineers flirted with the idea of walking with the Terminator, a slow, methodical crawl across the surface, always staying at the exact point where day becomes night. Imagine camping on the edge of a knife, except the knife is moving at 10 km/h and has trust issues. You look up, that big swollen sun glares down. It's 2.5 times wider in the sky than what you're used to. Shadows here are razor sharp, no fuzziness, no blur, just high contrast light that makes every rock, every crater, look like a dramatic stage set. And suddenly you notice something else. The color of Mercury's scum, there isn't one. It's pitch black even in the middle of the day. Because there's no air to scatter light, the sky stays as dark as midnight. It's like walking on a lit-up movie set surrounded by eternal space. Bright ground, dark sky, and your brain quietly screaming, "This feels wrong." It's beautiful in a please don't kill me kind of way. Your visor sensors ping surface temperature rising. Your suit's internal coolant has 10 minutes left at current output. The drone above you hums, adjusting its angle, creating a slightly less murderous patch of shadow. Time to head back. As you turn, your boots kick up another fine puff of silicate dust, microscopic blades shimmering in the light. You pause one last time, just long enough to take it in. The sun, the silence, the vast sunlit expanse of a planet that shouldn't be walked. And yet, here you are. Because the truth is, if we ever do set foot here, shade becomes survival. And Mercury? It offers none. As the Terminator line creeps toward you, the razor edge where scorching day gives way to freezing night. You step into the darkness and everything changes. Instantly. Your suit's sensors shudder. The temperature outside isn't just cold, it's violent. The kind of cold that turns metal brittle, that sucks the warmth from your bones through layers of insulation, like some unseen predator. Welcome to Mercury's night. You thought the day was dangerous? Here on the night side, the surface can plummet to 180 degrees. That's 290 degrees. It's the kind of cold that breaks materials designed for the moon. The kind of cold that laughs at antifreeze. Out here, even carbon dioxide freezes into dry ice. And the worst part? The night lasts forever. Because Mercury's rotation is weird. One full day, night cycle, one solar day, lasts 176 Earth days. That's longer than a Mercurian year. So if you land in the dark, you're not getting sunrise for 3 Earth months. Better hope your power supply doesn't run out, or your heating system doesn't get sad. Back in the 20s, spacecraft weren't even allowed to touch Mercury's night side. Too cold. Too unpredictable. Messenger, for example, avoided it like a cat avoids bath time. But now you're here, and you have to survive. Here's where internal heat cycling in your suit goes from nice feature to your only best friend. Your body temperature might be a stable 37 degrees, 98.6 degrees, but the world outside is colder than liquid nitrogen. Your breath fogs the inside of your helmet, and even though you can't feel it directly, the sensors on your lower legs are flashing. Warning, material stress accumulating. Why? Because the metals used in your boots, even the reinforced titanium carbon blend, are starting to contract under the cold. Tiny stress fractures form. In Earth conditions, they'd be harmless. But here in Mercury's deep night vacuum, one crack can spiderweb in seconds. And then it's time for a burial at 430 Kelvin. Historians still argue whether the first experimental night walk on Mercury was even successful. Some say it lasted 10 minutes before the astronaut had to retreat. Others say it was only achieved using robotic limbs and heated boots in an AI-controlled test mission. Either way, the notes were clear. The dark side of Mercury is not your friend. But here's the catch: the dark side has secrets. You see, Mercury's poles, particularly the permanently shadowed craters near its north pole, may harbor frozen water ice, actual ice. On a planet that kisses the sun, that sounds ridiculous. But these craters never see sunlight. Not in a billion years. Their floors remain in perpetual darkness, cold enough to preserve water molecules delivered by comets and micrometeorites. Back in the 2010s, NASA's Messenger mission used neutron spectrometry and radar to detect these patches. They showed up like quiet whispers from ancient impacts, proof that even in the hottest part of the solar system, cold keeps secrets. Some fringe scientists even theorize that these ice deposits could be harvested one day. Imagine that, human settlers mining frozen water in the shadows of Mercury, using it for drinking, radiation shielding, or fuel production via electrolysis. Of course, that would require habitats, underground bunkers, or lava tubes equipped with extreme thermal insulation and enough power to keep the interior livable. Speaking of bunkers, want to hear something delightfully weird? One idea that gained traction, briefly, and mostly in Reddit threads and off-brand tech conferences, was building thermo-hopper shelters. These were giant rolling habitats that would follow the Terminator line, moving just fast enough to stay between day and night. Like a mobile shade and warmth bubble, constantly riding the fine line between fire and ice. Sounds poetic, would probably explode. Back to your situation. Standing in the deep chill, every step you take sends little snaps and pings through your suit's outer shell. The suit's AI whispers calm updates. Energy levels, stable. Structural integrity, 92%. Cold stress, elevated. Recommending shortened EVA duration. You nod, forgetting it can't see you and keep moving. Your boots crunch over regolith that now behaves differently in the cold. During the day, it's dry and slightly loose, easy to kick up. At night, it binds together, clumps slightly, gets weird, almost like frozen dust. One step sinks, another skids. Your balance shifts. You adjust slowly. You pause at the rim of a crater. The inside is pitch black. Your helmet light clicks on, revealing jagged shadows and glints of something suspiciously reflective. Could it be? Tiny patches of ice or glass, hard to tell. Your instruments whir as they analyze the reflection. Water molecules detected. Confirmation pending. You smile, or try to. The muscle sensors in your suit pick up the motion and display a little smiling emoji on your visor's HUD. You didn't ask for that feature, but right now it feels nice. And suddenly you hear it. Well, feel it. A low rumble, deep, distant, almost too subtle to be real. It's not an earthquake. It's a micrometeorite impact somewhere kilometers away. Mercury doesn't have an atmosphere, so rocks don't burn up. They hit the surface full force regularly. That's right, no wind, no weather, but plenty of drama. Your AI chimes in again. Seismic activity detected. Risk level, low. Remain alert. Historians still argue whether these impacts could be used to map Mercury's interior, listening to the echoes, the way we do on Earth with earthquakes or Mars with Marsquakes. One camp says it's viable. Another says Mercury is too weird. As always, the truth might be stranger than both. But your time here is ending. The cold is creeping into your suit's outer layers, sensors showing rising brittleness in the material composites. You make your way back to the lander, slowly, carefully. Inside the module, warmth floods over you. Not much, just enough. The insulation kicks in, systems reboot, and you sit, breathing, surviving. Outside, Mercury's night stretches on endlessly. But for now, you've danced with thus darkness and lived. So here you are, back in the lander, fingers thawing, heart still racing from your dance with the dark. But there's something itching at your curiosity, something completely out of place in the narrative of a scorched, frozen, lifeless world. Ice on Mercury. You stare at the readings. They're not a glitch. There's frozen water buried in those eternally shadowed craters near the poles, shimmering like secrets hidden in the dark. It shouldn't be possible, and yet it is. And just like that, your next mission becomes clear. You pressurize your suit, prep your tools, and head back out, this time not to survive, but to investigate. The poles of Mercury are strange places. They never see direct sunlight, even though the planet itself is practically hugging the sun. That's because Mercury has almost no axial tilt, just 0.03 degrees. So the deep craters near the poles stay permanently shadowed, creating ultra-cold traps that even solar fury can't touch. Historians still argue whether the first detection of polar ice was made by radar reflections from Earth in the early 1990s, or whether it was MESSENGER's 2011 neutron spectrometry that gave conclusive proof. Either way, the results were jaw-dropping. Mercury, the scorched child of the solar system, had somehow preserved water. Real, usable H2O, possibly billions of tons of it. Fringe theorists, you know the type, have suggested that this ice might be ancient cosmic time capsules delivered by comets, trapped for billions of years in the cold embrace of shadow. Others go further, claiming that these frozen pockets could harbor chemical traces of life. Not life itself, mind you, just the building blocks. Think more space soup leftovers than alien microbes. You reach the rim of a shadow crater again, this one marked as a high-priority site. The descent is tricky. No light means no depth perception. Your helmet display overlays a wireframe map, guiding each step like you're walking through a virtual game level set to permadeath. Inside, the temperature drops to 200 degrees C. Your suit's system starts shifting into deep chill mode, redirecting heat from your core to the outer layers to prevent brittle fractures. You aim a scanning tool at the surface and the reading glows. Volatiles detected. You smile. Maybe you're the first human to physically confirm ice on Mercury. Sure, bots have done it before, but bots don't gasp in awe or whisper, "No freaking way," over a private comm channel. And the possibilities? They're huge. Water on Mercury means fuel. Through electrolysis, you could split water into hydrogen and oxygen rocket fuel and breathable air. It also means radiation shielding. Liquid water absorbs radiation extremely well, so future outposts could line walls with water tanks, turning ice into life insurance. And then the most basic possibility. You could drink it. Imagine sipping a cup of hot tea in a Mercury base, knowing it was once frozen in an alien crater older than humanity itself. That's not just survival, that's poetry. But there are risks. Mining ice on Mercury isn't like scooping slush from a cooler. The regolith here is mixed with silicates, sulfides, and carbon-rich compounds. Dig too fast and you risk destabilizing the delicate balance between frozen and fractured. Plus, any heat from your equipment can sublimate the ice instantly, turning it into vapor that escapes into the vacuum forever. Back in 2048, a robotic mining probe, Coldbite, attempted to extract a sample from a shadowed crater. It melted its drill bit, fried its circuits, and ghosted mission control within 16 hours. The lesson? Bring better tech, or pack holy water. You kneel down, your gloves tracing the edge of a glimmering patch just below the soil. Not all of it is pure ice. Some of it is hydrated minerals clays and silicates chemically bound to water molecules. Extracting that is harder, but not impossible. Engineers back on Earth were already developing microwave extraction systems that could gently heat the regolith and release vapor into collectors, then condense it in cooler chambers. You're standing on top of a space aquifer, a buried, ancient, frozen vault of resources just sitting there waiting. And the only thing between it and us is the cost of getting here. And trust me, it's expensive. Launching heavy mining equipment from Earth to Mercury requires mind-bending fuel budgets. That's why most future proposals suggest robotic prospectors first, then crewed bases after infrastructure is in place. You don't want to risk humans until you've mapped every crater, tested every extraction method, and triple-checked the power systems. And here's where things get oddly ironic. The same sun that tries to roast you alive, it might actually help you stay here. Solar energy on Mercury is absurdly abundant. Solar panels here could generate 10 times more power than on Earth. That's enough to run heating systems, life support, drills, greenhouses, heck, even Spotify Premium. Those signal delays mean your playlist might buffer for hours. Historians still argue whether Mercury's ice was the single most compelling reason for sending humans to the planet. Some say it was prestige. Others say science. But between you and me, it's always about water. Always. You finish your scan, mark the location, and rise. Your suit hums softly. You hear your breath again. The sun's light is creeping closer to the crater rim now, the Terminator crawling across the surface like a slow, inevitable warning. Time to leave. But as you ascend back toward your lander, you can't shake the feeling. Mercury isn't just a rock. It's a paradox, both hostile and generous, merciless and mysterious. It tries to kill you, sure, but it also hides gifts. And maybe, just maybe, it's inviting us to dig a little deeper. Back inside your lander, you review the data, heart still ticking faster than your suit's artificial pulse regulators would prefer. But even as the ICE scan results upload and the systems run cool diagnostics, one bigger, heavier question hangs over everything. Could humans ever actually live here? Not just walk, not just survive a few hours, but stay, build, thrive, even call it home. It sounds ridiculous. Mercury is the dictionary definition of hostile, a place where the sunrise means certain death, and nighttime is colder than a breakup in deep space. But it's not impossible. Not entirely. See, the idea of human colonization always begins the same way, with shelter. On Earth, it's about comfort. On Mars, it's about survival. On Mercury, it's about defiance. You don't build a home here because it's easy. You do it because the universe dares you not to. One early idea actually floated by some bold, red, semi-deranged engineers in the 2060s involved burrowing deep into Mercury's crust. Not for warmth, but for protection. Below the surface, the temperatures stabilize. Radiation drops. The regolith, rich in silicates and metals, becomes both shield and structure. Imagine a human outpost built into a crater wall, something like a sideways ant colony. Each tunnel lined with regolith melt panels, a technology that melts local soil using solar heat and resolidifies it into sturdy ceramic walls. Efficient, resourceful, not super cozy, but you're not here for the vibes. And then there's the issue of power, which, ironically, might be Mercury's greatest strength. The sun here is intense. Panels positioned on rotating towers called solar flowers could track the sun and generate obscene amounts of energy. We're talking enough juice to run fusion-level systems, advanced cryogenics, artificial habitats, even a full-scale greenhouse. Yes, a greenhouse on Mercury sounds like the punchline of a cosmic joke. But if you bury it under reflective regolith, regulate the temp, and use hydroponics, it's more than possible. It's been prototyped in lunar and Martian analogs for decades. Just add water, good thing we found some, huh? Fringe futurists even imagined a Mercury colony not staying put, but moving with the Terminator line. Like a slow-motion train nicknamed the Mercury Crawler, it would follow the thin band between day and night, forever surfing the knife edge of survivability. The colony wouldn't fight Mercury's extremes, it would ride them. Sure, it sounds like sci-fi, but remember, Airliners once sounded crazy too. Historians still argue whether a Mercury base should be robotic, semi-automated, or permanently crewed. Some think it'll be an AI-maintained facility used mostly for solar research and rare element mining. Others see it as a training ground, a brutal first step in prepping humanity for even harsher planets. Because if you can live on Mercury, you can live anywhere. But okay, let's say we go for it. We build a base, we survive. What's next? Communication. You're on a planet that's both too close and too fast. Mercury zips around the sun in just 88 Earth days, and it rotates slowly. That means long blackout periods if your base is on the wrong side of the sun during orbit. That also means your loved ones back on Earth might have to wait real-time hours just for your, "Hey, I'm alive," ping to reach them. To fix that, engineers proposed a relay network of solar orbiters, tiny satellites in dance-like orbits around the sun, keeping a comms line open between Mercury and Earth no matter the angles. Like space pigeons, but with lasers and better manners. And speaking of lasers, solar research on Mercury could unlock breakthroughs we can't even imagine from Earth. Standing this close to the sun, you could study solar flares, coronal mass ejections, and even the elusive mechanics of the heliosphere with clarity we've never had. One particularly bold experiment involved a sun-facing observatory embedded in the regolith, shielded by a massive automated sun cap that opened only for brief observation windows. They called it Project Icarus. It got shut down for budgetary reasons. Read, someone almost got cooked, but the concept still floats around academic circles. Still, life here wouldn't just be about work. Humans need more than function. They need meaning. That's why one section of the proposed base design is labeled the cave. It's not an actual cave, it's a dome. A dark, quiet space. No data, no duties, just peace. Star projections, artificial breeze. A place to sit, to remember Earth, or to dream bigger. Because here's the thing Mercury teaches you. Survival is just the first step. What comes next is belonging. The fringe becomes the frontier. The impossible becomes normal. The planet that once seemed too hot, too cold, too close, and too distant becomes home. You've seen the extremes. You've stood where temperatures swing wider than the mood of a sleep-deprived AI. You've danced between sunfire and starlit frost, touched ancient ice, and imagined underground bunkers beneath a cratered skin. But Mercury isn't just a playground for sci-fi survivalists or the sun's favorite punching bag. It might just be the next gold rush. Not literal gold, though. Yes, some Mercury rocks are chemically rich. We're talking rare metals and exotic elements so critical to modern tech that they make oil and uranium look like second-tier collectibles. We're talking platinum group metals, iron, sulfur, and potentially even helium-3, a rare isotope that could one day power fusion reactors, clean energy without nuclear waste. If it exists on Mercury in usable quantities, and there's reason to suspect it might, thanks to solar bombardment, the value could be astronomical. You step back out onto the surface, this time not as an explorer, but as a prospector. Your tools? A geological drone swarm, nicknamed the Mercury mice, cute, round, scuttling bots, each the size of a coconut, fitted with drills, spectrometers, and a serious caffeine problem. Well, metaphorically. They zip around the surface, sniffing for anomalies. One chirps, it's found a vein of iron sulfide, likely from an ancient volcanic vent. Historians still argue whether Mercury was once volcanically active, or if its massive crustal scars are just from being walloped by meteors over and over. The current theory? Both. It's been hit, it's bled, it's healed. And deep under its baked crust lies a planetary core that's still mysteriously massive. In fact, Mercury's core makes up about 85% of its volume. That's weird. Earth's core is about 55 by comparison. Some theorize Mercury started larger, but lost its outer layers in a cataclysmic impact early in the solar system's history. Others suggest it simply formed that way, an overachiever in planetary density. Either way, that means there's a lot of metal here. And where there's metal, there's motive. Fringe economists in the 2070s began floating the idea of off-world resource arbitrage. Basically, mine Mercury, process it on-site using solar-powered refineries, then launch refined metals to low Earth orbit using magnetic railguns. Yep, railguns. Not as weapons, but as cargo accelerators. On a planet with minimal atmosphere, the idea kind of works. Problem: escape velocity. Mercury's gravity is about 38% of Earth's, which is better than Mars, but not trivial. To get cargo into space, you'd need to build launchers along mountain ridges, or install electromagnetic catapults that fire mineral capsules into orbit, where automated drones would catch them mid-float like giant cosmic mitts. Sounds wild? Maybe. But Earth's appetite for rare metals is only growing. Phones, satellites, EVs, robotics, every shiny object we obsess over needs the kind of resources Mercury might be hoarding. You brush your gloved hand across a jagged ridge, scorched by time and maybe by orbital debris. This rock? Probably 4 billion years old. Older than any Earth rock you've touched. It's been sitting here, waiting through every war, every invention, every poem, every heartbreak your species has ever known. Mercury remembers. Back at the lander, your MySpots are uploading a mineral map. Green zones for iron, gold for sulfur, and red blips for unknown composite materials, which is tech speak for something weird we'll worry about later. And then there's the ultimate curiosity, the hollows. Mercury has these bizarre, shallow depressions, like the surface just collapsed a little. They're called hollows, and no one fully understands them. They reflect brightly, sometimes shimmer strangely, and seem to appear in clusters. Some believe they form from sublimating material stuff turning from solid to wash under Mercury's intense conditions. Others think they're remnants of ancient activity, like lost planetary acne. One theory even links them to volatile outgassing, suggesting that Mercury might still, in the faintest possible way, be geologically alive. Not volcanic, but breathing. Fringe groups, often the same ones that sell moon crystals on Etsy, claim the hollows are signs of ancient alien mining, or that they're entrances to subterranean tunnels. No evidence, obviously, but still you feel the pull of mystery, like the planets whispering, "Keep digging." Your drone flashes a final alert. Time's up. Solar exposure climbing. You gather your samples, strap in, and begin pre-launch sequence. As the engines warm, you look out the viewport one last time. That surface, that raw, untamed scab of a world that no one really understands. It's not pretty, it's not friendly, but it's real. It dares you. It tests you. And if you're willing to sweat, freeze, and bleed just a little, it might just reward you. With mystery, with metal, with meaning. As you ignite the ascent engines and rise above Mercury's battered crust, the planet's brutal beauty unfolds below you. Cratered plains, shadowy valleys, vast impact scars glowing faintly in the low sunlight. There's no blue here, no clouds, no softness, just raw planetary bone. But your story's not over. In fact, the real mission is only beginning. See, getting off Mercury is more than just pushing launch. It's a masterclass in orbital gymnastics. Mercury's low gravity may help, but the sun's gravity doesn't. It's like launching a paper airplane inside a tornado. To escape, your trajectory must thread a needle between Mercury's escape velocity and the sun's gravitational pull. Too slow, and you fall back. Too fast, and you slingshot into solar orbit permanently. You're not aiming for escape, you're aiming for precision ballet, and that ballet depends on your window, a timing so exact that engineers lose sleep over it. Because even a 1-second error in engine burn can shift your path by hundreds of thousands of kilometers. Fun, right? But let's talk about the why of it all. Why go through the agony of launching from this hell rock? Why not just stay in orbit, send probes, collect data with fancy telescopes? Because there's a secret up here, something you can only experience in person. It's called the double sunrise. Let's set the scene. Mercury's rotation and orbit are in a unique resonance, 3-2 spin orbit. It rotates 3 times for every 2 revolutions around the sun. As a result, if you stand in the right place, the sun rises, pauses, reverses, then rises again. Yep, it backtracks across the sky like it forgot something. Only Mercury does this. Historians still argue whether ancient civilizations could have predicted such a dance from Earth-based observations. Some point to strange carvings in Mesopotamian tablets as symbolic references. Others say it's just poetic coincidence. But the fact remains, this double sunrise is a spectacle unlike anything in the solar system. You see it now, through your ship's window. The sun beginning to creep over the curved horizon below, then pausing, then dipping backward just a hair, and then, with stubborn inevitability, rising again. It's not flashy, it's not loud, it's just otherworldly. And as you orbit, pulling away slowly from the gravitational grip, you can finally see Mercury as a whole. It's small, dense, scabbed and pitted, but unmistakably complex. You can make out the Caloris Basin, one of the largest impact craters in the solar system, 1,550 km wide. When it formed, likely from a comet impact billions of years ago, the seismic shock waves were so strong that they rippled through the entire planet in deformed terrain on the opposite side. We call that area the weird terrain because, well, no one had a better name for it. Fringe geologists suggest that Caloris Basin's formation may have triggered ancient volcanic activity or even briefly altered Mercury's rotation. It's a theory, an open-ended question that future Mercury explorers will be debating over protein bars and recycled air. As you float now in low orbit, system stabilizing, you check your instruments one last time. Data streaming, hull integrity, 98%. External radiation climbing but manageable. Time for the next trick. You're about to slingshot toward Earth or maybe Mars, depending on mission routing. That means another gravity assist, this time using Mercury itself to give your ship a gentle nudge toward home. These assists are an art. You're using the mass and momentum of entire planets to change your speed and direction without using extra fuel. It's like stealing energy from celestial giants who don't mind the favor. The first time humans used a gravity assist was with Mariner 10, which flew by Venus and Mercury in the 1970s. Back then it was a revelation. Now it's routine, but each maneuver still requires flawless timing. Miss it, and you're stranded in solar limbo, waiting years for another shot. Your ship's AI chimes in, grav window opening in 18 minutes. Plenty of time to take it in. And so you do. You look down on Mercury on a planet that shouldn't be interesting. No oxygen, no oceans, no moons. No atmosphere worth naming. And yet, it holds secrets. Secrets in its rocks. Secrets in its heat. Secrets in its silence. Fringe futurists dream of building solar forges, hear giant orbital stations powered by Mercury's proximity to the sun, using its metals to 3D print satellites, habitats, even spacecraft, right in orbit. A factory planet close enough to the sun to power the future. It sounds wild because it is. But so did Mercury itself not long ago. The sun flares in your viewport, dazzling and sharp. Your ship gently turns, aligning itself. The nav system locks onto a return vector. You close your eyes, letting the hum of machinery blend with your breath. You didn't just visit Mercury, you survived it, you learned from it, and in some weird way, you fell for it. By now, Mercury is just a glowing coin in the blackness behind you. But its pull lingers. Not the gravity your thrusters already broke free of that, but something deeper. A magnetic curiosity, a sense that you just left behind the solar system's biggest unsolved riddle. And maybe, just maybe, your path back to Earth will finally give you some answers. Because as your ship glides into its return trajectory, you realize something profound. We've been watching Mercury wrong this whole time. Back on Earth, we mostly see it as a fleeting dot close to the horizon, visible only at sunrise or sunset. Blink and it's gone. Astronomers called it the elusive planet for centuries. Even Galileo struggled to see it clearly. He wasn't sure what it was. Historians still argue whether ancient astronomers from Babylon or Egypt first spotted Mercury. Some clay tablets mention a fast-moving star that disappears and reappears every few weeks. Others describe a twin of Venus, playing hide-and-seek with the dawn. One thing is clear, Mercury has always been a ghost on the edge of visibility, and it likes it that way. The planet is, quite literally, the hardest major world to reach in our solar system. Not because it's far, but because the sun is greedy. Any spacecraft approaching Mercury is pulled downward, spiraling faster and faster like a marble toward a drain. So instead of burning fuel to speed up, you burn it to slow down, which in space travel is absurdly expensive. Even robotic missions to Mercury take years. Messenger needed 6 planetary flybys just to settle into orbit. The ESA JAXA mission Bepi-Colombo launched in 2018, arriving in 2025. It's like sending a package by express mail and having it arrive after the next Olympics. But you've made it back. And with you, you carry not just data, not just samples, but a change in perspective. Take Mercury's magnetic field, for example. It shouldn't exist. Mercury's small size means its core should have cooled by now, yet it still generates a magnetic field. We don't fully understand why. Theories range from a partially molten outer core to wild internal dynamics involving sulfur, silicates, and solar weirdness. Fringe scientists have proposed everything from Mercury once hosted a magnetic superstorm to the planet is a fragment of a lost twin Earth that broke apart. Sound crazy? So did plate tectonics once. You scroll through readings on your ship's dashboard, core temperature estimates, density graphs, seismic echoes from micro-impacts. It's all incomplete. A puzzle with too many middle pieces and no edge. And yet, even the gaps in knowledge feel like progress. You replay a feed from your lander's final transmission, showing the surface shadow shifting slowly, revealing cracks along the regolith where ice may lie buried. Somewhere below that, iron and nickel churn. Above, the sun scorches down, shaping the planet into its strange paradoxical self. What makes Mercury so special? Maybe it's the intensity. Everything here is dialed to the max. Heat, cold, speed, speed, and the density, proximity. It's like the universe used Mercury as a sandbox into stress test reality. And that's why scientists are drawn to it. Not because it's easy, but because it breaks the rules. One of the strangest things you reviewed before launch was a theory about Mercury's resonance with Earth. Every time Earth orbits the Sun twice, Mercury orbits it 3 times. The same relative positions repeat every 116 days. It's almost like Mercury wants to be noticed on a schedule, like a cosmic metronome ticking in sync with us. Poets and mathematicians have written about this. Some say Mercury is the drummer of the solar system. Others say it's the messenger, true to its mythological name, speedy, elusive, bearing secrets no one else hears. And maybe that's the biggest reason humans will return. Not for water, not for minerals, but for mystery. Because Mercury isn't just a place you land, it's a question mark in orbit, a riddle carved in stone. And now that you've touched it, walked its surface, and escaped its gravitational grip, you realize something no textbook could teach. This world changes you. You'll feel different when you step back onto Earth. The air will feel thicker, the sun smaller, your gravity heavier. But somewhere inside, you'll still carry a little Mercury with you, a sense that the universe is wilder, sharper, and more intricate than you ever imagined. The nav system beeps, Earth approach locked, re-entry path plotted. And you close your eyes for a moment, not to rest, just to remember. You wake not with a jolt, but with that peculiar weightless sensation you only get in deep space, that gentle drift. The ship's artificial gravity systems are still throttled down to conserve energy. It's quiet here, peaceful. But your thoughts? Still anchored to Mercury, still spinning with its impossibilities. And now, as Earth grows steadily brighter in the window, you face another strange question. What now? Because you didn't just visit Mercury to plant a flag and grab a selfie. You were part of something bigger. The start of a conversation with the most misunderstood rock in the sky. And conversations? They echo. They ripple. Especially when Mercury's involved. Let's rewind. You recall one of the oldest theories that Mercury may have once been a moon. A captured satellite torn from a larger planet or even from Venus herself. It explains some things, its weird orbit, its heavy metal core, its lack of volatiles. But not all. Other theorists fringe, yes, but persistent claim Mercury was the victim of a planetary collision, that it was once bigger, fuller, more Earth-like, until something slammed into it, stripping away its mantle, leaving behind the dense metallic core we see today. a planetary crime scene still radiating the scars of ancient violence. Historians still argue whether this impact happened once or multiple times. Some believe Mercury was assaulted again and again in the early days of the solar system, that it's not just wounded, but survivor sculpted, maybe even still evolving, which raises an eerie possibility. If planets like Mercury can be shattered, reshaped, and stripped by cosmic trauma, so can Earth. Suddenly, this mission isn't just about curiosity. It's a cautionary tale. The sensors beep. Telemetry says you're nearing the magnetopause, the edge of Earth's magnetic shield. You feel it even before the instruments confirm. That sense of coming home. The gravity adjusts. The lights brighten. The AI hums awake in full, preparing for orbital deceleration. Welcome home. But you're not the same as when you left. You've spent time in a place where life is impossible, yet meaning is everywhere. You've walked on a planet with no wind, no weather, and no atmosphere, and yet felt more movement than in any city. You've seen sunrises in reverse, held ice older than human memory, and dodged solar radiation flares that could melt steel. And the craziest part? You miss it already. You scroll through your mission log, dozens of seismic records, core density data, spectrograms from the hollows, sample containers clamped and frozen in containment bays, each one holding a piece of Mercury's history. In one pod, a chunk of dark regolith from the crater wall, grainy, brittle, and unnaturally reflective. In another, traces of hydrogen embedded in rock, possibly comet delivered. And in the last one, sealed tight under triple vacuum protocol, a fragment from the polar region. It sparkles faintly under the containment light. Could be water, could be something else. No one knows yet. And that's the point. Fringe scientists are already speculating. Mercury dust might become the next moon dust, an entire field of study. Toxic, useful, magnetic. Time will tell. For now, the science community is salivating, and your inbox back on Earth will probably explode by the time you land. Which, speaking of, your ship enters low Earth orbit. A sea of satellites float lazily around you. Communications, weather, surveillance, trash. The AI begins aligning the capsule for re-entry. You look down at the blue marble. Clouds swirl, oceans glitter. It's too soft, too easy, too warm. And yet, it's home. You sigh, not with sadness, with gratitude. Because Mercury taught you something you didn't know you were looking for. That survival isn't always about comfort. That understanding doesn't come wrapped in answers, but in mystery. That sometimes the most valuable resource a planet can offer is perspective. And just before the descent protocols kick in, just before the capsule drops and the heat shields flare, and your body begins to remember gravity, you whisper it, "Thank you, Mercury." The capsule breaks through the thermosphere like a meteor, politely knocking at Earth's front door. Plasma dances along the whole superheated air, glowing orange-white outside your viewport. The ship vibrates, groans, shudders like it's reliving every G-force you've endured up to this point. But you're still. Because after Mercury, this is nothing. You've already withstood the kind of cold that snaps metal, the kind of heat that makes volcanoes blush. Earth's re-entry feels like a warm bath. As you streak down toward the landing site somewhere in the Pacific Recovery Zone, you begin thinking about what comes next. Not just for you, but for Mercury, and for everyone who dares to go where you just came from. Because the data you're bringing home, it's not just numbers. It's a provocation. You've confirmed the water. You've mapped the metals. You've tested survival. And now the world is watching. Before you even splash down, think tanks, private space companies, and government agencies are already spinning up simulations, sketching out blueprints, pitching Mercury development initiatives with acronyms like MERB, Mercury Extraction and Resource Base, or Helios, Heavy Element Logistics for Interplanetary Operations and Sustainability. The acronyms are terrible. The ideas? Not so much. Historians still argue whether the Moon or Mars will be humanity's first true space colony, but Mercury's quietly entered the conversation. Not because it's easy, but because it might just be the most useful place we're not talking about. Let's be real. It has abundant solar energy, precious metals, water in shadowed craters, and a magnetic field to help shield delicate electronics. Combine that with deep regolith cover, and you've got a shot at long-term human presence. The only catch? Everything. Mercury demands perfection. Fail and you get cooked, frozen, irradiated, or flung into space like a deflated beach ball. But succeed, and the rewards stretch across centuries. Fringe futurists are already talking about solar edge economies, colonies not on planets like Earth, but on extreme solar border worlds like Mercury and Io, places where danger creates opportunity, where resource availability isn't limited by atmosphere or agriculture, but by who's bold enough to walk into the furnace and come back with gold. And you've done just that. As the parachutes deploy and your capsule slows into its final descent, the ocean comes into view, a mirror of cloud-streaked blue. But you're not looking at the water. You're looking at the horizon. Because you know Mercury isn't the end, it's the beginning. There's talk of building a Mercury cycler, a spacecraft that orbits the sun in a path timed to repeatedly rendezvous with both Earth and Mercury. Sort of like an interplanetary bus route, saving fuel and time, enabling more missions, more people, more infrastructure. The backbone of a real space trade network. There's also renewed interest in surface tethers structures anchored to Mercury's crust to help lift materials into orbit without the need for rockets. Once thought impossible due to extreme temperature shifts, now they're being reconsidered thanks to new memory alloys and Mercury's surprisingly stable geology. Historians still argue whether we'll ever terraform other worlds. But Mercury forces a better question. Should we? Why try to reshape planets into Earth clones when we can adapt ourselves to survive in their wild uniqueness? Mercury isn't waiting to be Earth 2.0. It's daring us to evolve. Your capsule thuds gently into the sea. Buoyant stabilizers deploy, bobbing you upright like a sleepy cork. Sunlight flashes off the ocean surface, the same sun you saw from much, much closer just days ago. And suddenly, Earth feels like a postcard, fuzzy, pretty, a little unreal. The recovery team is already en route. Hovercrafts cutting through the waves, drones buzzing with cameras, voices crackling in your earpiece. Welcome back, explorer. How was Mercury? You smile. How was it? It was like walking on the raw nerve of a star. It was like trying to survive in a myth. It was like hearing the sun whisper back. And now the whispers are going public. You've brought Mercury home. And it's about to change everything. You're out of the capsule now, wrapped in post-mission blankets, blinking into camera flashes, politely nodding through the debriefing nod fest that comes with re-entry. The science team swarms the return module like kids around a birthday cake, already scanning, labeling, preserving each Mercury artifact like it's sacred. And honestly, it kind of is. Back at Mission Control, they replay the footage of your landing, of the double sunrise, of the hollows breathing in the darkness. Everyone's stunned, but what really floors them is something smaller. It's the sound. One of your drones, equipped with an ambient vibration sensor, picked up resonance frequencies from deep within Mercury's crust. Barely audible. Some rhythmic, others chaotic. But one frequency stood out. A near constant, low-pulsing beat, a planetary heartbeat. Not literal, of course, but something was resonating. And now acoustic engineers are analyzing it like it's a lost verse from the universe's oldest song. Historians still argue whether it's seismic harmonics from ancient impacts or the effect of Mercury's iron core rotating inside its solid mantle. The poetic ones, they're already calling it the sun drummer. You smile at that, not because it's scientific, but because it's beautiful. Back in isolation, for health reasons and to make sure you didn't bring back space bacteria, of course, you find time to reflect. In a sterile room, under the gentle hum of fluorescent lighting, you pull out a small tablet and review the mission logs. You didn't just explore a planet, you made first contact with possibility. Mercury, in its silence, taught you that exploration isn't about comfort. It's about curiosity that hurts, that burns your suit, that scrapes your boots, that nearly fries your circuits and fractures your sense of safety. But Mercury also showed you resilience. You remember stumbling across a rock, scarred on all sides, clearly cracked in a dozen places, scorched black. But in the middle, a shimmering vein of glass-like crystal, likely formed from a high-speed micro-impact infused by intense heat. Nature's repair job, raw, ugly, but dazzling. And you remember standing near the edge of that crater? Just you, your suit's breath system, and the faint buzz of radiation against your sensors. In that moment, you felt something you'd never expected to feel on Mercury. Peace, because everything trying to kill you was also everything keeping you awake, alive, alert. Earth dulls you sometimes, with comfort, with repetition. Mercury sharpens you, and you realize this is the blueprint for the next chapter of space exploration. Not grand cities in the stars, but outposts on the edge. Survivable, not utopian. Functional, not flashy. Places where humans don't conquer the planet, but make a deal with it. You give Mercury respect, and in return, it gives you secrets. Fringe architects are already sketching rotating polar colonies, built on rings that turn slowly, always facing the same narrow strip of twilight. The design, a hybrid of lunar shelters and deep-sea submarines. Durable, cold-adapted, permanent. Others suggest underground vaults to store genetic archives, AI cores, or solar weather data, just in case Earth ever needs a backup. And then there's the art. Yep, Mercury-inspired art is trending. Sculptures using blackened basalt, music composed from seismic rhythms, fashion lines imitating the scorched silver textures of your suit. Mercury is no longer a forgotten rock. It's an aesthetic. You receive a message from a child in Tokyo. I watched your landing, it reads. I want to be like you. The kid's 6. You stare at that message longer than you expected, because in some small, roundabout way, you helped Mercury speak, and someone heard. Weeks have passed. You've left isolation. The interviews have faded. The suits are back in storage, and the bruises from the G-forces have finally stopped throbbing when you roll out of bed. But Mercury, it hasn't left you. It haunts you in the best possible way. You find yourself staring at the sunrise differently now, wondering how Mercury's would have looked today. You trace the arc of the sun in the sky and mentally compare it to Mercury's double dance. Earth feels slow, clumsy, spoiled almost, because you've been to the edge. And once you've done that, every comfortable moment is laced with a subtle whisper. You could be more. That whisper follows you into meetings, into conversations, into dreams, especially the dreams. You keep dreaming of the hollows, those impossible shimmering depressions you passed over in your rover. You remember the reflection they gave off, not like sunlight on glass, but like light bending slightly wrong. Some physicists now believe they may be signs of quantum instability in Mercury's crust. A stretch, sure, but is it? Historians still argue whether similar anomalies exist on Earth. The zone of silence in Mexico, the mysterious rumbles beneath the Himalayas. We've always had places that don't quite behave, but Mercury wears its weirdness proudly out in the open, across entire plains, and that weirdness is catching. At universities across the globe, enrollment in planetary science has surged. Students aren't asking about Mars anymore. They're asking, what about Mercury? Engineers have already built a Mercury rover prototype nicknamed Chimera, low profile, solar adaptive, radiation hardened, designed to burrow underground when surface temps rise. Its wheels, modeled after armadillo claws. Because Mercury doesn't reward elegance, it rewards toughness. Private space companies have proposed joint missions. One wants to send a robotic ice harvester. Another, a Mercury-based observatory to study exoplanets using the planet's stable rotation. A third wants to build a data vault, a kind of galactic library encased in regolith and sealed away from time. You know it won't stop there. Mercury has shifted from afterthought to aspiration. It's even entering pop culture. There's a new drama series in development, Sunborn. You've been asked to consult. The pitch? A team of misfit scientists races against solar storms to decode ancient signals hidden in Mercury's polar shadows. Is it realistic? Not even slightly. Will it inspire the next generation? Absolutely. Because here's what Mercury gives us: the romance of the impossible. It's not cozy like Mars, not dreamlike like Europa, not mythologized like the moon. Mercury is hard, ugly, perfect. It doesn't offer paradise. It offers clarity. Remember that sound your drone recorded? The low-frequency pulse in Mercury's crust? They've mapped it now. Turns out it wasn't just random seismic noise. It had structure, not language obviously, but rhythm, consistency, a pattern. They've played it through speakers and sound labs. It's hypnotic, meditative, like Mercury itself is humming a lullaby forged from ancient iron. And you can't stop hearing it, even here back on Earth, lying in a soft bed, wrapped in gravity and breathable air and filtered light. You still close your eyes and feel that beat, that subtle, stubborn rhythm. Boom, boom, pause, boom, boom. You realize Mercury's not just a planet, it's a metronome of resilience, a place that tells us the harshest environments can still hold grace if we're brave enough to look. You look at your hand, the one that brushed ancient regolith, and smile. Because soon someone else will land there, and they'll leave their own footprints, ask their own questions, hear their own beat. You just lit the path. Time has passed, not years yet, but enough. Enough that you've watched the Mercury mission evolve from headline to history, from breaking news to school textbook, from you were there to you were part of it. The world has changed around you quietly. Your face has become shorthand for space ambition. You've been turned into an emoji, a bobblehead, a museum exhibit. They even named a crater after you, small, sharp-edged, and oddly near one of the hollows. You joked about that once. Now it's real, but Mercury isn't done with you. Not by a long shot. See, something strange is happening. The hollows, those shimmering depressions, are spreading. Slowly. New ones have appeared since your visit, identified by satellite passovers. Spectrographic changes. Their shape and reflectivity match the ones you stood near. But they're in different regions now. It doesn't make sense. Fringe theorists are exploding with ideas. Some say internal chemical processes are triggering slow evaporative collapses. Others think it's tidal stress from the sun. The spiciest theory, that the hollows are evidence of ongoing geological life, not biological life, planetary life, a form of planetary metabolism, a slow exhalation of Mercury's past through processes we still can't model. Mercury, alive in its own alien way. Historians still argue whether this qualifies as a living planet. The concept has always been controversial. But if any planet could flip that paradigm, why not the one closest to the sun? As the debate rages, new missions queue up. The next one? A twin lander study sending synchronized rovers to opposing hemispheres. One in constant light, one in constant shadow. The goal? Compare seismic readings and magnetic flux between regions that never see each other. You were invited to lead the training team. You said yes without blinking, because now you understand. Mercury doesn't just test you once, it keeps asking questions. And the moment you think you're done, it changes, shifts, expands, like a story retelling itself with better grammar. Back at the Planetary Sciences Lab, you hold a sample from your mission. Just a chunk of rock, black, pitted, slightly metallic. But in the microscope, a fractal lattice no one's been able to replicate in lab conditions. A mineral matrix born of extreme cycles, melted, frozen, cracked, reheated, over and over, endlessly. That rock is a memory of pain, of pressure, of adaptation. It's familiar. You carry it in your pocket sometimes, not for luck, for perspective. Mercury taught you that survival isn't about comfort. It's about learning to exist as you are in a place that refuses to accommodate you. And sometimes, it teaches you more about Earth than Earth ever could, like how fragile your atmosphere is, how rare your oceans, how lucky your magnetic field. You remember standing on Mercury's edge, suit battered, oxygen low, staring into the dark seam between night and day. That seam runs across your dreams now. It reminds you of balance, of contradiction, of possibility. And in a few months, you'll be going back. This time with better suits, better data, more questions. but still no answers. Because Mercury doesn't give those freely. It only offers silence, scorched beauty, and the echoing hum of a world that refuses to be understood. And you'll keep listening. Wind down. 300 words. You're floating now, not in space, but in memory. The hum of Mercury's silence still lingers in your mind, like the faintest lullaby, drawn from stone and starlight. You feel the weightlessness of space in your fingertips, even as Earth's gravity tucks you in. Let your breath slow. Let your heartbeat match Mercury's rhythm, steady, distant, eternal. Boom, boom, pause. The room is dim. The air is soft. Maybe there's a fan whirring gently nearby, or the faint hush of night traffic outside your window. Let those sounds blend with the ones in your mind, the crackle of solar radiation, the crunch of regolith underfoot, the deep stillness of a world untouched by wind or rain. You're safe here. No heat waves, no solar storms, no mission clocks ticking in your ear. Just rest. Let your mind drift across the stars and settle slowly on that small, dark planet once more. Let it become smaller, then smaller still, until it's nothing more than a speck against the backdrop of the sun. A tiny molten marble spinning endlessly, whispering secrets to the void. You don't need to understand it. Just listen. Just breathe. Because tonight you are part of something bigger than sleep, bigger than space. You are part of the question. And somewhere between silence and sunrise, Mercury is waiting.